Let's find the integral from 16 to 4 of the square root of 1 plus square root of x over square root of x dx. To solve this, we have to use a u substitution. We'll let u equal 1 plus the square root of x. Du will be 1 over 2 square root of x dx. So now these limits are in terms of x. So if we plug in x is 16 in here, we have 1 plus square root of 16 is 5. Plug in 4, we get 1 plus square root of 4 is 3. And then the square root of 1 plus square root of x, well, 1 plus square root of x is u. So we have the square root of u at the top. And then dx over square root of x, well, if I multiply both sides by 2 here, I do end up getting 1 over square root of x dx. So I have to multiply by 2 du. And now I'm going to integrate. So u to the 1/2 is u to the 3/2 times 2/3, and then multiply that by 2. So that's just 4/3 u to the 3/2, going from 5 to 3, which this is the same thing as saying negative 4/3 u to the 3/2 from 3 to 5. Okay, because whenever you switch the limits, you have to put a negative sign. Although it's not necessary, so I'll show you both ways. You'll get the same answer. So here you plug in 3, you have 3 to the 3/2 minus 5 to the 3/2. This one you would have negative 4/3, 5 to the 3/2 plus 4/3, 3 to the 3/2. And then 3 to the 3/2 is just 3 times 3 to the 1/2. And then 5 to the 3/2 is 5 times 5 to the 1/2. So same thing here. So here I can factor out, or we can have like 5 times 5 to the 1/2 plus 4/3 times 3 to the 1/2. And then let's see here, if you distribute, you have 4/3 times 3 to the 1/2. The 3's are going to cancel. You have 4 times 3 to the 1/2. And then you have 4/3 times 5 is 20 over 3 times 5 to the 1/2. Now the other way, here you would have negative 20 over 3 times 5 to the 1/2 plus 4 times 3 to the 1/2. So either way, you're going to get the same answer. So this step right here, when you switch the limits and put a negative, was optional.